anytime you are working mathematics and something happens to be a blocking stone or anything, right? Just take it out. Please, I didn't say remove it totally. Just take it out silently. Then later you bring it in. Now, so that is the concept. So n will come out. N you are disturbing us, please go out for us. As you can see, n is gone. Now n into m squared. I get this. N goes here. I'll get a single n left. You see, I'm free. N goes here. That is n squared. Good. So anytime you are doing mathematics, something seems to be disturbing, you just push it aside small. You can't remove it totally. Take note. Just push it aside small. When you finish, you bring it in. Good. Because in maths, nothing goes out, nothing comes in like that without any proof. So you have this. Now let me make the assumption here. There is 1 mn minus 1 mn. Why am I saying minus 1 mn minus 1 mn and not positive 1 mn plus positive 1 mn? We are talking about a minus here. Plus n squared. Good. Now the 3-term expression has become 4-term. 1, 2, 3, 4. Good. So the reason why we make assumptions in quadratic is to make them 4-term. Now this work is not quadratic, yes. You can say this like a polynomial here, friend. But since it's 3-term, you can also use the same thing. That's what we have done here. Good. So I factor m out. M goes here, 1 m is left. M goes to m and I have n. Minus here, I factor n out. N goes here, positive m. N goes here, minus attacking positive as negative n. Good. What do we see here? I have n. I can factor one of these. Then put those outside together, as you can see. Good. I can still see this compressed. Good. So that is how it goes. So the secret is that anytime you see a 3-term, there's a 3-term. 1, 2, 3. A 3-term expression. Make an assumption on the middleman and get 4 terms so that you can what? Do your method of grouping. That is the main reason why we do that for quadratic. So take note. Okay, let's look at this. So this is also a sample WASI question. Factorize completely this. Now, it looks like we are free here. 1, 2, 3, 4. A 4-term expression. Now good, so we want to group. And this side is not going to work. The 9r is odd. Now what is the trick? Anytime you are working, something seems to be odd in mathematics, separate it silently, right? I didn't say remove it totally, just separate it, right? So if the 9r is worrying us, right, we can get it off, not totally, right, but somehow, you see, we keep it out. Okay, so we want to look at our situation, and when we finish, we bring it in. Because it is disturbing us. But you cannot clean the 9r from here. No! You can't just clean things in maths like that. It doesn't go that way. Before you clean something, you have to show a proof. Whether it's cancelled and it disappeared, fine. You don't have the power to do that. So as I said, any element you see in mathematics disturbing you, yes, you can take it out, right? And you work, you bring it in. You don't leave it out, you still bring it in. Good. Now there's a 3-term, as you can see. 1, 2, 3. Wow. So I will still make assumption on this. Mn minus mn plus this 9r squared out. Now do you know when I put 1mn minus 1mn, I will produce minus 2mn? That makes my assumption correct. So what I will do is that I will be doing method of grouping here. So m squared minus 1mn minus 1mn plus n squared. Now the 9 out. So I have this m out, m minus n. I factor m out. I factor n here, m, I can see plus. Why should it be minus? Minus n against positive, that's negative, right? Good. Keep it out. So this and this, I pick one, good, and I put them together, m minus n, I put them together here, I put them together here, I put them together, good. So what are we seeing here? We have m minus n, right? Good. So this and this, the compressed form, you have this. Now this can also be this. It's common, you see, we just separated it secretly. So is that no difference of two squares? Yes, it is. There is 110, there's also 110. So that is m minus n plus 3r. Also, the whole of this minus that. Please, you are not writing this minus because of this. No. This is what makes the difference of two squares. So this plus this in one chamber, this minus that in one chamber. That is it. Good. So that is how far algebra can go. Okay. So let's look at operations on algebraic fractions. So I have a minus b over 3 plus 3a over 2. I have to use what we call the LCM approach. So I have this. Now LCM is the combination of the two denominators. This is called a numerator. This is a denominator. Combination of the two denominators gives us the LCM. So that is 6. Or it can be combined in this way. Any of the method you want to use. It is still 6, as you can see. Now 3 will go into 6. You get 2 times the 1 on top. Now what is the temptation here when you see a student doing this? The students will end up writing this. That is wrong. So please, anytime you are multiplying a number by an expression, introduce what we call parentheses or a bracket. Good. So that you can see that you get 2a minus 2b, not 2a minus b. The other way around. Now 2 will go here, you get 3 by the 1 on top. So that is how we do LCM. So this goes here 2 by the 1 on top. Now this goes into this 3 times by the 1 on top. See, I like using bracket a lot. I hardly write times. That's not wrong. But I always want to maintain precision. Now, when I say 2 going to 6, that is what we mean. You get 3. Good. Now, when you do LCM, that is what you are interested in. The side. So you can see you have 2a minus 2b plus 9a all over 6. So this and this are the same. You have 11a minus 2b all over 6. Now this thing can be partitioned this way. It's possible. Good. You can even go further to even get this. Good. That is it. So that is how it goes. So take note, when you have plus or minus between two fractions, you do what we call LCM approach. Plus 1, m minus 1. You can see some 3-term expressions here. Now let's go. So before we do any form of LCM, you have to make sure that you have done some form of simplification, right? Now there is difference of two squares. There is m squared. You see, here it's supposed to be 1 squared. Just that 1 square is still 1. So difference of two squares with 1, you hardly see a square. Good. So there is m plus 1, m minus 1. Always open up. Simplify before you take your LCM. Always do that. It makes the work very easy. Good. So take note. This is difference of two squares. This is not difference of two squares. This can be difference of two squares. So 1 is 1 aside some other numbers is one of the odd numbers that are difference of two squares that you hardly see them with a square here like this, right? So 1 square is still 1. So you hardly see 1 square. So take note. M square minus 1 in this form is a difference of two squares. But this is not. So I put my denominators together. M minus 1, m minus 1. I pick 1. No repetition. M plus 1. Good. That is what I have. Now we have 3-term approach here. Now the whole of this into the whole of that. That is what it means, please. M minus 1, M plus 1, all over what?